Good morning, good evening, everyone. We should be live. Can you hear us? What about the sound? Do you have any echo? Okay, okay, so far so good. Try to. Okay, so let's get rolling. Welcome everyone for yet another workshop online, and today I am with a very special guest, Raoul Sig. Hi Raoul, how are you?
Hey, I'm doing well. Thanks, Cedric. Thanks for having me again.
Yeah, so try to put your slide in full screen. I like to get a little bit of shout out to you in slide 2. I don't know if you see my last minute slide. So, and yes, for those who don't know Raoul, so he's a very important member of the Cassandra community. So first, he's the CEO of Anan Corporation, but he's also, and his team, creator of Cassandra.link, which is a super great resource to get all the news and article about Cassandra. And he also created and maintained Awesome Cassandra, where you find all the links for tools and, great articles. But not only that, in the website you can see that they have cloned Awesome Kafka, Awesome Spark, Awesome Solar. I mean, everything that can contribute to the community, those guys are everywhere. And not only that, he's also managing multiple meetups group in the East Coast. So thank you very much, Raoul, for being with us today.
Thank you. Thank you so much. Appreciate that. Just wanted to tell everybody, thank you all for being here. Appreciate you guys coming out. I'm in the East Coast, so it's kind of like the lunch hour, but some of you may be coming from Europe or Asia or the Pacific West here. This is part of a series showcasing an event-driven toolkit. And the first presentation, which is also which was Cedric and I hosted this before. It's on YouTube. And this particular workshop is going to build upon that one, in which we built a simple REST API on Cassandra. Today, we're going to be covering event-sourced API on top of Kafka, because you can do event-sourced API on different systems. And we're going to connect Kafka to Cassandra. We're actually going to be very ambitious here. We're going to be doing 3 ways.
In 2 hours.
Using the consumer. Yeah, in 2 hours. So we even thought we could fit in the Spark component, but no, that's impossible. So that means even though you can try to follow along, I recommend just focusing on watching what I'm doing. You can always come back to the video later. The content is well documented. In fact, you'll see I'm going to be literally copying and pasting from the README that is online and it's open source. So you can always come back and do this, right? So today, what are we covering? Well, we're going to be talking a little bit about event-driven API. What is an event-driven API? How does that really fit into the world of microservices? We're going to talk a little bit about Kafka topic modeling. If you've done Cassandra topic modeling, Cassandra data modeling, you'll find that there are some similarities in this idea of partitioning, but it's not exactly the same. We're going to open up the code. We already have code, so that's a prerequisite. If you had, if you didn't have an Astra account before, you need an Astra account. There's another repo. We're going to be looking at 2 repos, Cassandra.realtime and Cassandra.api on GitHub. Both of them we're going to be opening up in Gitpod, which is a self-contained web-based IDE. And we're going to do a couple of different things. We're going to be creating topics, messages, consuming them, and saving them into Cassandra in a few different ways. So you get an idea of how to leverage Kafka with Cassandra. Main takeaways are that you get a basic understanding of Kafka topic schema partitioning. We're not going to make you an expert today, but you'll get a basic idea. You'll understand the basics of Kafka, the Kafka API. Again, you're not going to walk away a Kafka architect today, because frankly, we're going to be dealing with one node Kafka cluster. In real world scenario, we're gonna, we're talking about potentially several, types of clusters: Zookeeper, Kafka, etc. But what we want is that you understand how Kafka can work with Cassandra. Kafka can work with many different technologies, but today we just want you to take away that how Kafka can work with Cassandra. Just wanted to give a shout out to our sponsors. Gitpod has been very, very good to us and to DataStax in giving an amazing platform to do self-contained development. DataStax has been a great sponsor, and Deloitte has also been involved in beta testing some of these workshops. So thank you, everybody, for making this possible. What is an architect? So I went to Google and I said, what is an architect? And the reality is an architect is a chief builder. And in computing, it's to design or make things. So our company, Adonat, we architect platforms on Cassandra and related technologies. We love Cassandra, and Cassandra is the heart of many of the platforms we work with. We love dealing with anything that's scalable. With DataStax, it's a lot easier. That's really what I like to tell people. Even though we've used all of the open source technologies, Apache Spark, Apache Cassandra, Apache Kafka, when we use things like DataStax and for that matter, Confluent, it makes life a lot easier. That's where we come from. Technology is great. It's even better with commercial partners. So some of the different ways that you're going to be able to experience this and find out about this is actually, Cedric, you want to talk a little bit about the different platforms where people can watch this?
So we are live
workshop?
on YouTube. This is where you're watching us probably, but we also live on Twitch. We can use Twitch as a backup. We're not really tracking the question on Twitch. So for question, it's mostly the YouTube chat and also a Discord. So we are using a Discord room for every workshop. We are more than 7,000 people there now. So if you need more deep dive question, go to the Discord, and we are a full crew of advocates at DataStax that would help you in Discord. We did a Menti quiz, okay? Yeah. And for the workshop and for the hands-on, this is what I put. The database is Cassandra running into Astra, cloud-based as a managed service. And we are using one first runtime for the API, provided by Gitpod, and another one which is dedicated to Kafka.
Absolutely. And the best part about this is that you don't need a powerful computer to do this. In fact, the very first workshop I did, which was just on the API, I did it on a tablet through the browser, through the Chrome browser. So it's amazing what we can do these days. So one of the first things, if you were following along, I would say is to go and launch Gitpod. Gitpod is a platform in which, it's basically like a Visual Studio Code, but it's not exactly. It's actually the Eclipse via IDE. And I'm just going to make sure that my Gitpod is up and running. It takes a while. It's built on top of containers. It kind of runs, builds these images. And I'm also going to warm up my Cassandra API Gitpod. As you'll see, some of these, depending on if you've done this before, it may come very, very quickly. Other ones take a little bit longer. And what I've done here is just, bless you. What I've done here is I went to the URL for Cassandra.realtime, this repository, and I just clicked on Open with Gitpod. That's it. And this is what I have running now. Same thing with the Cassandra.api. Looked for this icon, Open with Gitpod, and it's bringing it up now. And when you're up and running, you will see a terminal, like a Linux terminal here. You will see your folders with all your content. And if you click on a file, like let's say this Docker file, you'll be able to edit that file, right? That's when you know this is working. Back to the presentation. While that's running, and we may have to warm it up again depending on where we're at. Some of these Gitpods, they become dormant, they'll shut down, so we'll come back. What is Gitpod doing for us? Gitpod is giving us an operating system. It is giving us a IDE where we can edit code. It is giving us a proxy in which when we run an API, REST API, it'll dynamically map that port, let's say port 8080 or 8000 to a URL that we can access. So it's doing a lot of different things for us. I'm just going to say Gitpod is magic, and then we can move on. If you're interested in the technology, all the technology that Gitpod runs on is open source.
Yes,
and so you can always look into that.
And also because, just a word, because we are a good user of Gitpod, we will be with Gitpod next week during this workshop. I will be with an advocate from Gitpod, and we will run through all the small features. So next week.
Awesome. That's great. Yeah, we love Gitpod. They sent us a bunch of stickers. They're an amazing organization. That's all you need to do. Just give us stickers and I'll call you out. Why are we building this application? So this application that we're showcasing, this workshop series, it's not just a play, it's not a toy. We're actually using this technology on a part of our company's operations. This is the larger picture of our knowledge platform we used to inform ourselves. We could have always gone and subscribed to something. We really didn't like something out there, all of the apps out there. So we decided to use a combination of open source tools. And what this is a diagram of where our knowledge base data is stored, where it's indexed. It has an interface for administrating content. It also has interfaces for browsing, as well as we publish websites out of this knowledge base. Cassandra.link is actually a site published from this knowledge base, right? So this is a real world use case for why we do this development. It's not just to play around and do a workshop. We actually do use this technology. Where we're going, where we want to go, is to have everything serverless. Absolutely everything serverless. Right now, all of our web interfaces are already serverless. We're using things like Zeit and Netlify. The Astra examples use Gatsby and Astra with Netlify. We use Gatsby and Netlify right now. We may actually use some of the Astra APIs later down the line. In terms of the databases, there are some databases that are already managed. So Astra, we have not quite 100% migrated over, but we're about to. And then we're using a separate service called ServStacks for managed Solar Index. The storage attached index, the new one on Astra, is good, but Solar is a different type of technology. And what we're going to talk about today is this part right here, which is how to consume events and process them into Astra, because a big part of our transformation from where we are to where we want to go is to make this a scalable, reactive platform that is 100%. Just a quick overview of microservices and how it, and REST versus event-driven architecture. They're related, but they're not all the same. What is a microservice? It is a loosely coupled, basically a unit of it's a process that's loosely coupled with other loosely coupled services. It can be implemented using asynchronous or synchronous. Most people, they interact with microservices as a REST API. They will make a REST API that has one function, one database, and then there's another system that calls it. Others may be familiar with using microservices with Kafka, or let's say with RabbitMQ, in which their events are driving the execution of these microservices. Normally, people go into microservices because they want to have a system that can scale independently, so that we can, replace features very quickly without having to redeploy the whole system. This is a big discussion. A lot of people have different terminologies with what microservices are, but I just wanted to have you guys understand that we're talking about microservices right now in terms of having a simple function over REST, over HTTP, and we're actually going to be doing a bit of that with Kafka streams as well. Now, there's a different subject of microservices on Cassandra. A lot of folks will say, well, if it's a microservice, then it should have a separate database. Every single microservice needs a separate database. When we come to the world of Cassandra, we can actually host several different microservices on one cluster. And you can have a microservice powered by one table, or you can have a microservice powered by a whole key space, or potentially even having a microservice powered by a whole data center, right? And one of the biggest benefits of Cassandra is that it has a multi-model system built in which you can write data with CQL, tabular format, and retrieve it via JSON, right? And then if you are looking at data stacks, you can actually write data via CQL and retrieve it using Solr, so in an index, to arbitrary queries, or in the newer versions of data stacks, there's actually DataStax Graph, where you can write data via CQL and then request data back via Gremlin. So Cassandra is a game changer in the microservices world. And if you are, if you've ever worked with a mature organization that's using Cassandra and microservices, you'll see that they have large clusters powering hundreds and hundreds of microservices. And that's the reality. This is not the same database. This is not your father's database. This is a different type of technology that can empower you to do huge platforms on one or two clusters. Event-driven architecture is a way to do microservices. It's a way to do different architectures. When we talk about event-driven architecture, most of the time we're talking about how to implement something called CQRS, Command Query Request Segregation. Or we're talking about how to sequence a set of different microservices to do a job, to do a saga, for example, right? And in our case, we're using PubSub in Kafka essentially to say, this is an event that came in and we want to process it in a certain way. Event-driven architecture is another very complicated, I wouldn't say it's complicated, it's a different area of architecture that most organizations eventually get to if they want to scale their platforms. And so this, just kind of going back, organizations that start to mature their platforms, they go to microservices. Some of them end up using Cassandra. And eventually all of them start to use event-driven architecture, because that's really the only way to create global platforms. You just can't have everything tied together with synchronous calls. That's the beginning of distributed computing. That all came out because one big machine couldn't do everything. Now we're at Apache Kafka, all right? We talked a bit about event-driven. We didn't get into it, but we will see in Kafka how to do event-driven APIs. Before we do that, let's talk about what is Kafka, when to use it, and why to use it. So Apache Kafka is actually a combination of a few different services. Most folks, when they talk about Kafka, they're talking about the broker, but Kafka is actually an ecosystem of separate tools and technologies. Generally speaking, a Kafka cluster has a zookeeper ensemble, which hopefully sooner than later they're going to take out. It's already in movement right now. And the zookeeper ensemble is what coordinates the cluster, and it coordinates different consumers and producers. The Kafka cluster itself has several brokers. Now, this is the minimum viable Kafka, right? Just to have a cluster of brokers and the broker's responsibility is to accept messages from producers and to allow consumers to then consume messages from a particular topic. Kafka is built on just an idea of a distributed message or distributed log. And the way they scale is by keeping that log replicated in several different servers. So if one particular server goes down, then that message is also available on a different server. A lot of the scalable platforms out there are some implementation of a distributed log. Kafka is a literal distributed log. All it really is doing is it's saving messages in a log and it's replicating it and making sure that it's available at scale. So remember when I said that Kafka is a combination of different technologies? So Kafka, most of the time, is, when people say, what is Kafka? Well, Kafka is the broker service, right? And it involves clusters, clusters of brokers. We have different topics. I would say a topic is like a table. And then we have partitions, which is a way to clump data together, like similar to in Cassandra. And then we have the actual messages, which are like table rows or records. Kafka is not the different ways to connect to Kafka, right? So Kafka client API, which includes the consumers and producers, and there's different client APIs for different languages like Python or Java or Scala or Node. or Go. I mean, you name it, there's a way to connect to Kafka. That is not Kafka. That's just the Kafka client. Kafka Connect is not Kafka either. We're going to be using all three of these today, by the way: Kafka Client, Kafka Connect, and Kafka Streams. Kafka Connect is like a framework. I would say it's a lightweight, enterprise service broker. It's very, very lightweight. It allows you to connect different things to get data into Kafka and take data out of Kafka and put it somewhere else. And finally, Kafka Streams. It's a way to do stream processing without necessarily needing Spark, for example, or Flink. You can just write a little program and do very basic stream processing using the Kafka Streams API. There are other helpers, and these are amazing helpers, but they're also not Kafka, right? The Kafka REST proxy is a way to get data into Kafka without you creating your own API, your own REST API, right? You can just stand this up and have a ready-to-go API. And it works with something called the Kafka Schema Registry. And the Schema Registry also works with Kafka Connect. The Schema Registry is important in an enterprise where you may have several different systems talking to Kafka. The Schema Registry allows you to have a contract between different people connecting via Kafka. You don't need to have Kafka REST. You don't need to have Kafka schemas. You don't need to have any of this stuff to use Kafka except for the broker service and Kafka client. But all of these things make your job a lot easier. You'll see. Why do people use, or when do people use Kafka? Well, it's both. It's when you are big enough, you need to use Cassandra in a similar way. When you're big enough, you need to use Kafka. It basically outperforms any matching technology that's out there that you can download and install. And we're not comparing, let's say, Amazon SQS and Google PubSub. We're talking about technologies that you can download and install and scale on your own. It beats everybody, right? Kafka beats everybody. Who uses it? Well, LinkedIn, who made it, people at LinkedIn made Kafka. They use it. Uber, Netflix, Comcast, they all use it. You can find this in their engineering blogs. You can find this in their GitHub repositories. A lot of folks use Kafka. It works well with other technologies that scale well, like Cassandra, like Spark, like Flink. It works well with these technologies because Spark and Cassandra, as they scale linearly, Kafka can also scale linearly to global scale. There are other technologies that are now Kafka compliant. So there's another Apache project called Apache Pulsar, which is it's engineered slightly differently, but you can actually use Kafka client API to talk to Apache Pulsar. Whenever I see two different technologies or three different technologies using the same API, it means that this technology is there for a while. It's not going to go away anytime soon. All right, so that's a good signal that there's another technology using the same API. One of the biggest gotchas with any distributed system, whether it's Cassandra, whether it's Kafka or Spark, is that people don't understand that distribution or scale from distribution only works if you distribute the work, right? So in Cassandra, if you model the database in which the data is clumping on certain partitions, wide partitions, or on servers, hotspotting, that problem comes from a design issue. That same problem can happen in Spark when you have tasks that are heavier than others. In Kafka, we can have a similar problem, right? Just because the technology is very powerful and it distributes, it doesn't mean that your data is going to distribute. So one of the first lessons we want to learn about Kafka is that messages are partitioned, and there's different ways to partition messages. But partitioning, what it does, it does two things. One, it can group messages together so that, let's say, one consumer can read from it. That's one reason to have partitioning. Another is that it allows us to load balance so that several consumers, for example, can process the same type of messages. Other technologies have mechanisms to do routing and whatnot. This is the way we do routing in Kafka, right? We determine our routing strategy, we determine our partitioning strategy, and that's how we can spread the data, spread the load. So here's an example where we have one topic, different consumers can pick up from different partitions. That means that there's no importance to the message, versus we can have different partitions for a particular topic in which we say, partition 0 is the high urgency message line, and whereas partition 3 is a low urgency partition line, and these consumers can be scaled dependent on urgency. The data in Kafka is replicated. It's not the same as Cassandra, but its effect is the same in that it allows us to have millions and billions and sometimes trillions of messages coming in on a daily basis, and systems can then read those messages billions of seconds, billions of messages per second, and process that. When a server goes down, the leader, another one gets elected. Okay. Again, I'm not going to get into the specifics of how, but Zookeeper is what allows the system to quickly know who is the new follower, who is the new leader, who are the
just
new
a question about partition. Do you know if they are static or dynamic in Kafka?
Sure, that's a good question. It is up to you, and I'll get into that in 1 second. Basically, your partitions are either you give the partition yourself in the message. In that case, you're dynamically creating this yourself, right? And actually, let me come back to you. What do you mean by dynamic or static partitions?
Oh, so I think I just read the question, but I expect that. Can you fix in advance? This is the partition name, and every message that would get this property will end up this partition, like a group by. Or because it's dynamic, I get too many messages on the topic, I need to split and do a partition. This is how I understood the question.
Got it. Yes, that's a good question. So when you set the message, right, you can give the partition in that message. Once it's written, it's written, and we'll talk about rebalancing partitions later. There's different tools to do that. But as far as pure Kafka is concerned, it's like in a Cassandra table, right? When you set the partition key, that's what it is. And the only way to really move it is to then write a new partition and move that data over. There are ways to have the system automatically distribute the data. So if you don't give it a partition ID, then basically Kafka can do that redirection for you. It can balance it based on just a percentage. And then finally, there's round robin. But in each of these cases, if you want to rebalance your partitions, there are different tools to help you do that. And Confluent has a couple of tools. There's open source tools out there as well. So to answer your question are they static or dynamic? After you've set them, they're fairly static, but there's ways to change it if you want to later. It's not, well, I don't want to say it's easy or hard. It's just a matter of what scale you're dealing with, right? If you have a small scale, it's pretty easy. If it's a bigger scale, it's a little bit different. All right. So, in this case, this diagram just shows that you have control over how to partition your messages. The strategy is a big part of Kafka architecture. Beyond the how do you scale Kafka technology itself, this is the way you scale your messages. This is the way you make sure the data gets spread properly and consumed properly. There are existing partitioning algorithms. You can also make your own, right? There's classes that you can inherit from and make your own partitioning strategies. Random partitioning will take messages and put them on different partitions, versus, let's say, you can decide group by, right? I want to group by particular messages, partition. We can put everything in one partition if it's a particular, let's say, key, right? And then by guarantee, this is what I was talking about earlier. You can have one partition that has high guarantee versus low guarantee, and it's how you consume the messages that allows you to really do that. And last reason why people would use Kafka is its web scale. If you've ever watched this little YouTube series about Mongo and why Mongo is web scale, you'll get the joke. But Kafka is web scale. There are actually 2 or 3 different technologies that allow Kafka to scale at the global level. One way is by just the topology, right? The topology being that you have several different Kafka clusters that then report into a global Kafka cluster. There are other ways to use a technology called Mirror Maker that will replicate data, similar to how data is replicated in data centers in Cassandra. But I would say it's still not there. Very few people need Kafka at a truly global web scale, and they're the ones who are tackling it, like Netflix and Uber. They're the ones who are coming up with these technologies. But if you are watching the lists for Kafka user group, or if you're watching some of the blogs, you'll see that they're trying to do this within the core technology, meaning not necessarily using something else outside of Kafka. There are lots of different use cases for Kafka. The main use case that started it all was basically LinkedIn wanting to connect different databases to different services and keep them consistent. And they ended up basically making a unified distributed message log where systems would write to that message log and other systems would read from it. This is the reason they made LinkedIn. They made Kafka at LinkedIn. They wanted to connect their systems together. Today, people use it for everything under the sun. Folks will use it for aggregating logs from hundreds and hundreds of servers. Some of them will use it for, let's say, stream processing. We're actually going to be using it for event sourcing. Meaning we're populating the topic with events, and then we're going to be processing those events. Every industry that I have personally worked with I've seen at least one company use Kafka. And that just comes with the territory, right? Like if you're working with Cassandra, you're going to work with companies that are pretty big. And so they end up using Kafka for e-commerce, for IoT or edge computing. I can't talk about the specifics on this workshop, but trust me, if you're using a brand that's a pretty global or national brand, they're using Kafka and probably Cassandra.
Yes.
All right. So, quick review of Astra, which, if you've been watching these workshops with Cedric and other team members from DataStax, you know what Astra is. Astra is a Cassandra as a service, and if you want to go over the features of Astra,
so
Cedric,
indeed, at the heart, core is really Cassandra as a service in the cloud. It's a managed service. We are doing all the backup and management and scaling for you. And not only that, we provide tools to use Cassandra on top of it. So development tools like the Studio, and also now some API on top of Cassandra, REST API, GraphQL API, ready to go, and more's coming. So DataStax Astra is really now a platform to ease the usage of Cassandra as much as possible.
Excellent. And as you can see, there are, just like with Cassandra, you have different drivers. You can use the same drivers to talk to Apache Cassandra, at DataStax Astra, as if you were talking to Apache Cassandra.
Yeah, you told about CQL before. Yeah, so here is all about CQL, the way you used to interact with Cassandra. It's exactly the same with Astra. Simply add a couple of parameters and certificates to secure the connectivity between you and Astra, but it's all the same. And now Astra have even more ready to go REST API if you, for instance, a JavaScript developer and don't want to cope with the Node.js driver anymore, but simply want to do REST code, it's now possible.
Absolutely. So for us, as app developers, why do we use Astra? Well, frankly, we know Cassandra well. We help clients scale Cassandra. Why should we use Astra? Well, it's because we want to focus on the features of our platform. what matters to us. The general trend at our clients, and as we've seen in the industry, is to go towards serverless. We don't have the time to manage our own servers for an app like this, right? So it makes sense to use something like Astra. And if we use Astra, we can scale our applications and we can build faster the features we want, rather than having to go and check the health. Well, we can still check the health. There's some tools on the Astra interface, but honestly, nobody wants to manage servers. I don't know if you want to manage servers, go work for DataStax. They can put you in their Astra team. But at our clients, and ourselves, we want to focus on our business, right? We don't want to necessarily have to worry about servers. Let's quickly launch Astra. Actually went ahead and warmed up my database earlier. So if you log into Astra, normally you'll see an interface to create a database, and you can choose the free tier. I've already used up the free tier, but you can then choose either production or high density production workload, and then you'll choose a cloud provider, which region you want, and it'll show you how much it costs. I've went ahead and done that already. So I have a database running, which I call it platform. And in this database, it's first of all, it's running in Google Compute and US East. And right now I have one key space. I can add other key spaces if I want. But that's it. It's it's Cassandra with a really nice interface. If we want to see how the health of the server is, as I mentioned earlier, I can check to see, like, for example, how much data is in there, general requests served, and you'll see earlier I was doing some reads and writes at high speed. I can go see what happened. There is a CQL console. The CQL console is basically the same. I haven't seen too many differences in this CQL console. I'm going to just zoom in a bit. Oops, too much.
Oh yeah.
And I have my key space here, but then there are also a couple of other ones out there. So everything you can do in CQL you can do here, except maybe like copy files, because you don't have access to copy into or copy out of. There's also a studio interface here, which it allows you to do basic visualizations. You can run any type of CQL insert, update, delete command here. Immediately see the output. You can also browse data in here just to make sure that you're getting what you want in there. We'll come back to the interface as we go through the demo. Just a reminder, right, where are we going? We want to make this a serverless platform and not have to run any code ourselves. And what we're talking about today here is taking data for a URL, and we're scraping some of the content, and we're saving it into Cassandra. That's what we are storing. We're storing a cache of a URL, and we're tagging it, and we're categorizing it. Right now, we're focusing on this part of the diagram, which is the actual items. And right now, we have not implemented collections, meaning collections of links, and we have not implemented identities, meaning users, on Astra yet, but that's where we're going. And we also want to have a cache for metadata, which we don't necessarily want to pull from the internet every single time. So that's why we can use a separate database for that. As I said, anybody can go to astra.datastax.com and create an account for free. Now to have sign in with Google, sign in with GitHub. These credentials, are what are hard coded into the code that we're using. Although I have separate credentials. Once you're logged in, you'll see CQL if you want. You can see DSC Studio and also the Grafana interface. More resources about all the things we're going to talk about today are available on Cassandra.link. We also have a site called Cassandra.tools, which is a subset of the knowledge base. DataStax is a great resource for all things Cassandra and DataStax. I would say they have the best documentation out there for Apache Cassandra and DataStax, as you would expect. And to find out more about Kafka, go to kafka.apache.org or Confluent. They're the commercial vendors of Kafka. Now we're ready to go into the hands-on portion. We're going to be going through the steps fairly quickly. As I mentioned, I don't expect you guys to follow along 100%. Remember, all of the stuff that I'm doing is online. You can copy and paste exact same commands, except maybe the passwords, and it'll work. Once we start up our Gitpod, the four things we're really focusing on are creating topic schemas and verifying them. We're going to create and consume messages with Python. And then finally, and that's using the Kafka consumer producer API. And then finally, we'll use Kafka Streams and Kafka Connect as alternative methods to get data from Kafka into Cassandra. Gitpod, amazing IDE. Let's go ahead and pull it up. Make sure that our interface. See, this is what happens when when you don't use a Gitpod instance for a while. It takes a couple of seconds for it to start up, but it's not as slow as if it was the first time that you were pulling it up. The first time it really has to build an image for you and so on and so forth. While that's happening, in DataStax Astra, I'm just going to show you that there's some content in my database, right? And what does that look like? And you're not supposed to be doing this count star, but I did. I just wanted.
Thank you, Raul. Thank you.
Here's 1,000 or so. There's about 1,000 rows in here, right? And once we're done, we're going to expect to have a bunch of content in there. What kind of content is it? It's basically a URL. It's the content that is scraped from the URL. There are some incoming and outgoing links that we store in here. There's a preview picture, right? That's not that many columns. And I'm just going to truncate it because I don't want you to think that I've baked it before and that's how we did it. I want you to see that I've actually gone through and populated the data using this code, right? So and then if we do a select, there's nothing there. And then if I do a, so there should be nothing there, right? We now have an empty database. As I mentioned earlier, there's two Gitpods. One is the code that exposes an API. Cedric mentioned that there's different ways to use Astra, including ready-to-go GraphQL REST and REST APIs. We intend to actually use some of those, but the goal of this code was to show how to connect to Cassandra using Node or Python. And you can customize that code. These two versions are they're synonymous. They work exactly the same. They're just same implementation, different technology. And to make this work very quickly, what I would do is I would go here and I would download the Secure Connect bundle.
You got it.
Which I've already downloaded. Okay. And I'll go up here and I'm just going to upload it. Cool thing about Gitpod is you can just drag and drop from your desktop. So I'm just going to go ahead and upload this. And it's done. All right, there's my Secure Connect bundle. I'm going to go ahead and change my username in my credentials file. And I didn't drop my table, so it's already there, okay? And I've set up my credentials now. If you want to know how I did this, how I knew what to do, you can always go to this API repository and walk through the examples, right? Everything that I'm doing here is documented for you to check out. The first thing that I need to do is to get data into Cassandra just to make sure that the API is working. I'm going to do that. And what I want to make sure is that my API is working okay, right? So if I go into my just installing some of the requirements.
Oh, Python, you miss a H.
Oops. Python is not a technology, apparently. Not yet.
Yeah.
Maybe next year. Somebody will come up with something called Python. And this is saying, sorry, I don't like you. Let's see. Interesting. Well, I don't have to, sorry, I think I'm going to go and just run the API. We'll worry about the data import the other way.
Please?
Yes. I'm also going to install okay. All right, and then I'm going to run the API for Python, the Python version of the API. And oops. Cool thing about Gitpod is that when you have any APIs running on a different port, it can just expose it. By the way, this is working. I just don't have an endpoint defined here, but this is good. We know that the API is up and running. I verified it. It's showing up. We are good to go here. Next thing we're going to do is in our real-time code, the Kafka code. I'm going to walk through starting Kafka. In fact, I don't have to do that. I don't have to start Kafka because as part of the Docker image for this Gitpod, I've already set to Confluent to go ahead and start all the components. So as you can see, and I'm going to zoom in here so you can see as well, Confluent is it's like a cheat code for Kafka. Just like DataStax is like a cheat code for Cassandra. When you use it, life is a lot easier. So when you start when you start Confluent, it's starting Zookeeper. It started Kafka Broker. It started the schema registry. It started my Kafka REST API. It has an instance of Kafka Connect, and it also has something called KSQL. We're not going to be looking at KSQL today, but it's just it's a system that comes as part of Kafka. When we start Kafka, by very nature, it's like an empty database, right? It's just nothing is there. It's not configured. So the first few things that we have to do is create a schema, create a topic, just like any other database. Now, if you've used GUIs before, there are some open source GUIs for Kafka. we're not using the Confluent interface today. We're actually going to be using something called AKHQ, which I think Cedric has also used in the past.
Yes,
just a
so
very
the
simple
main
tool
developer is
to
based
take.
in France, and it's my friend, so please use it.
There you go. There you go. So, well, what we're going to be doing, the very first thing we're going to be doing is, in order to get ready to get data from this Kafka instance into the other API, we're going to copy and paste our URL that we exposed earlier. And I'm just going to copy this. And in here, I'm just going to make a new notes file. And I'm just going to put my notes in here. There we go. Now we have the interface, the API URL. We have Gitpod running. Let's run a command to create a topic, okay? When you see this $ Confluent home, or when you see $ project home, these are environment variables that we have set up to make it easier for you. And in order for us to make it easy for you to run this outside of Gitpod. You don't have to run this stuff in Gitpod. You could clone this repository and run all of the examples using Docker on your own computer, right? So in order to make it synonymous, we put these environment variables in here. Where did my copy go? So I'm going to copy paste this line right here. And if you cannot see the text, what it's doing is it's saying, run a tool called Kafka Topics, create a topic here called record Cassandra leaves Avro. And Avro is a way to do schemas in Kafka. We're not going to get too much into that today, but we'll briefly talk about why Avro schemas are useful. Go ahead and run this. This is a Java program. It created a topic for me. Awesome. Now, what I want to see is I want to make sure that my command, it did work on my Kafka. And if I list the topics, it should tell me, hey, here you go. Here's a topic for Cassandra leaves, as we made earlier. There are other topics in there. So everything that is a underscore is an internal Kafka topic that helps Kafka run itself. Some of these are really more focused on Kafka Connect and the schema registry. And then the ones that are prefixed with with Connect are for Kafka Connect. And then this is for KSQL. In a vanilla Apache Kafka, you're not going to see some of these things. Okay, you're really not going to see anything at all. You're just going to see this. Now that we have Kafka running, we have a topic. The next thing we're going to do is create a schema. And a schema for us is like in a Cassandra table. It's a way to structure our information. When we generate some messages, I'll actually show you the difference of data in Kafka without a schema and with a schema. And we'll talk about why do we need a schema. So when we talk about schemas in computing, in architecture, there's like two schools of thought. One school of thought is, oh, you don't need schemas. We don't need schemas for anything. I'm not in that school. It's because I've learned better. It's like when you make an API, right? Why would you make an API that has absolutely no structure? Just like you wouldn't create a REST API and with a schema and then document that REST API for other people to use, I wouldn't want to make a table without a schema, or I wouldn't want to make a topic without a schema, because a schema is basically a contract between systems. The benefit of things like Cassandra and Kafka is that you can change your schema and it doesn't hurt the system. But I'm a believer in schemas, personally. We can have a conversation offline if you don't agree.
No, schema are good,
so
even in Cassandra.
Even in Cassandra, schema is great, exactly. And there we go. So we have installed some prerequisites, and the prerequisites were for a Python program. You can look at that code later, but all this is doing is it's going to be helpful for us to create schemas and manipulate these things. To do that, we need the drivers, right? That's what the app, the requirements are for. I'm going to run this command to create a schema, and I'll show you a preview of the schema. Right, let's take a look at what this file is. So we made a schema using this Avro schema file. What does that look like? So Avro schema basically is okay, there we go. An Avro schema basically is like a table schema. It says, here are my fields, right? Here's a field called is archived, it's an integer. Or if I have structure, if I have arrays inside a field, I can also put that. So I'm not limited to having a flat schema. I can have a hierarchical schema if I want. And it's important for us to have this schema because when we map from Kafka to Cassandra, if they're using similar types, the system will not have to do any special, parsing and concatenating and all of this random stuff to make that thing work. If it's an integer, it'll get mapped to an integer. If it's a string, it'll get mapped to a string. So having a schema in Kafka allows us to connect to Cassandra better down the line. All right. Oh, now I was complaining about the preview interface, and now that I don't have it. There we go. You got the schema. Let's verify that schema is created, right? So if I curl, sorry, my mouse is doing funny things today. Go back here. There we go. So I'm going to curl just a local host. I don't have to really go to the outside world. And it's telling me that I have a schema available to me, right? So we're good. We did create a schema. And then I'm going to run a tool to verify this using AKHQ. And just a recommendation, when you run this command, run it in a different terminal. So go to terminal, open a new terminal, because I want to be able to have this running while I do other things, okay? And it takes a few seconds for it to come up, but it'll say I'm running. Let's open this up in the browser. And this is an open source tool you can use with any, instance or Confluent instance. There we go. There's our schema. There's no data in here, obviously, in this topic because, well, we haven't created any data, right? So this is running in one screen. That's good. And next thing we're going to do is import some data. And we're going to be importing data into the topic first. We're not doing anything with that data. We're just importing it in there. This is something to note, right? Kafka can be taking messages for you and essentially, keep those messages for you without having anything down the line do anything with that, right? That's huge. So let's say you have a system that's using Cassandra, and you have another system, let's say that's using MySQL. Your messages can be imported and processed to both systems if you wanted to. All right. Okay. Most of my requirements requirements are installed, and I'm just going to go ahead and paste this. So the data import code is fairly simple. It actually writes to a couple of different topics. You can take a look at that later. I'm going to just double check to make sure the configs are correct. Right, so we've got the connection information, localhost, localhost, localhost. So there's nothing here that wouldn't work. Right, so let's go ahead and run this command. And what it's doing is it's actually reading a file, just a JSON file, and it's sending the data into Kafka using two things. It's using the REST proxy, and it's using a schemaless topic. So when we go to AKHQ, you'll see this is the Avro topic. If I click on it, I see that it has structure. Right? This is the data that we populated using the REST proxy, which uses the schema. However, if I look at the other one, which I created without using any topic, without using any schema, the data is there as well, same amount of data, right? Looks like it's the same, but it's not. In the schemaless topic, it's just one big string. That's it. That's all it has. So Kafka can do what you want. You can do it with a schema, without a schema. I like using it with a schema because it allows us to do further things like we'll see with Kafka Connect. Or if you wanted to use something like KSQL, you could use that too. So we started Kafka, we created a topic, we created a schema, we populated the data using a program just to dump data in there. The Python consumer API is fairly easy to use. It's all documented. Again, we're not going to walk through the code today, but it's fairly. I think Python is probably the easiest way to get started with this stuff. Right? Change the code, run it. It's fast. If you want, you can run this program to see the same messages via a command line tool. It takes a second, so I'm going to actually open up a different terminal and run this. So we had sent about 1,000 different messages. These are the messages that are now available inside Kafka. I've talked to folks and they said, why do we need Kafka? Why can't we just write it to Cassandra? Well, that's the whole purpose of having an event-driven API, right? If we have events coming in centrally in a unified log, in this case, we're using it to store data about URLs, then let's say in our use case, we want the data to be then persisted to Cassandra. We also want to index it and put it into Solr. And maybe we even want to do some machine learning API to it to extract some smart tags or some smart topics, right? One event in Kafka can then spin up several different processes. And let's say we make a change in our code, right? Let's say we make a change to our schema. We can go back and run our code on the same exact topic and basically replay all the messages. That ability in Kafka allows us to do migrations. So if we want to migrate from one code base to another, as long as we can read the schema from Kafka, we can repopulate a database using that information. This is just one of many reasons to do event-driven. But when people do stress tests with their software, their next version of their software, what they'll do is they'll say, just replay the topic, replay from Kafka, all of the events in our system, and see how it manages, right? That's a great way to load test your system. So this thing is going to take a second to replay all the messages. I'm just going to go back to the code here. Our next thing that we're going to do is we're going to be looking at our code from before, getting the API endpoint, which is here. And we're going to go back to our Cassandra real-time and point our software to that URL. Let's see. Excuse me. So this is an example file, and I'm going to first copy it before I, you know, make a modification to it. There we go. I'm going to get rid of this thing here. So in our properties file for our Kafka streams example, you know, you don't have to touch anything up here. And if you wanted to change the offset later, you could come back. But this is the way we could, you know, replay the messages. Our key space, we're going to change it to what we have in Astra. Our table is called URLs. And API host is not, it's not localhost, it's the URL that we have from here. Since this is a part of a Scala application, it's not as simple as with Python where we just change some code and run it. We're actually going to be compiling this. We could have done this in an interactive way, but we wanted you to get the feel of basically running a Kafka Streams example. In Kafka Streams, what we're really doing is we're looking at a message, and one item at a time, we're processing it into the API. The code is all Scala. If you've ever used Java, Scala is kind of similar. It's not exactly the same, but it's similar. It's simpler to look at.
More or less.
More or less. How about this? The more you know in Scala, the less you program. Because you get
yeah, that's true. That's true.
You get really, really good at making really concise code. So that's
that
what
nobody
I like
understood.
Which nobody understands. Yeah, right. So we did this. We have to compile our code, right? And to package it, we use something called Maven. You can use Maven. You can use Simple Build Tool. You can do a lot of different things. In my case, Maven is the most, I would say, the lowest common denominator. Every project I work on eventually ends up using Maven to do everything. So why not just play with that? Anytime you make a change to this config file, by the way, you'll have to run this because the config file is packaged as part of this jar. But hopefully, you know, you're not going to have to do it too many times. There we go. And the moment of truth is going to be when we run this file, when we run this program with this properties file, that all the data that is currently sitting in Kafka, right, it's just chilling for us to do something, all the stuff that's here, is going to make its way into Cassandra. So let's see.
I don't know if you will get
because
the message into Cassandra, but you're just downloading half of internet already.
yeah, I know. Since we actually process the messages, I'm going to recreate the messages using the data import API.
Oh yeah, it has been consumed already.
Yeah.
So the messages are still there, right? It's just the consumer that...
They're still there. Yes. And if I guess I could have gone into the config and said the offset is 0 and then basically replayed from there. But I want to see, so right now we have a consumer that is just sitting around waiting for the stream, right? Nothing's happening. And I'm going to go ahead and start dumping some data into that. All right. And here we go. So it's doing something. And by the way, it's not perfect. There are some errors that come up. It's part of the API processing. Let's see what's happening on DataStax Studio. So let's run. Ah, we have some data coming in. Nice.
Cool. Clap, clap.
And then let's see if we do a select star.
No, don't do select star, man. Put the work close always. You want to break my machine.
So I would agree, but we're not going to do more than 1,000.
Oh yeah,
URLs,
okay,
so.
okay.
Okay, so it's processing, right? So data is coming in. The messages have been put into Kafka. We verified that here. We have another program written in Scala that is picking up the messages from Kafka and saving it into Cassandra. And then we're verifying with CQL here that data is coming in. So while this is happening, let's take a look at briefly at the differences between the code, right? I'm going to minimize this a little bit. One part of the code that we have here is Python, right? So there's a program here that takes data from this, there's like a JSON file, and sends a message to Kafka. One way is that it sends it using the REST API, the REST proxy. The other is that it just sends the data itself. Okay. So for example, here's a method, send one with schema, and here's another one we're using the REST proxy, and here's one that sends it without a schema. So if you want to see the different ways of doing it, you're more than welcome to download this code and see how. Sending with the schema, when we send it with the schema, we're basically saying, before I send the data, I want to make sure that it meets the criteria for my schema, right? And the way we're doing it is that we're going to be using the same schema file that we have as what we used before. So how do we do that? First of all, that's the reason why we have a schema registry. When you send data to a topic that is using a schema, we first talk to the schema registry and say, hey, let's see if my data actually meets the requirement for the schema. Then when we send the data, it can basically save the data properly. It's a little bit more involved, but it works every single time. If you have bad data, it'll kick it out. Now, to send data without a schema, you don't have to do anything special. You just say, hey, put the data in here. I'm done. But this causes issues potentially in the future where you want to do something like KSQL, or if you want to do something like Kafka Connect, you're not going to be able to do that because KSQL and Kafka Connect and Kafka streams expect structure. Okay, they expect a structure to be able to take the stream, to make it into a K table, and so on and so forth. Scala, on the other hand, is in our code, we're using Kafka streams. This is different from the Kafka consumer and producer API. So our Kafka code is using the Abra schema as well. And I don't know why the Scala language interpreter is not showing any of the syntax here. But what we're doing here is eventually, after all of our little formalities of how to connect, essentially we come down to, processing a stream. And here, let me see if I can zoom out. Let's see this better.
Yep.
Yeah. Too small.
Too small.
Yeah, it's too small.
Who said that Scala was concise code?
Well, hey, so trust me. This is more comments. These are comments. These are.
I trust you. I know. Just kidding. I like Scala.
Yeah. There we go. I'm going to actually jump right into the record processor, so you get an idea what we're doing here. Is once we read the message, okay, we're actually sending it using a REST API to Cassandra. You don't have to do that, right? You can have a Kafka Streams app written in Scala that reads from Kafka and directly writes to Cassandra using the Java API, right? The driver itself, and that's actually how most people will probably end up doing things with Kafka and Scala and Cassandra. Mm-hmm. Having an intermediary step for us was to just show to respect the idea of microservices, we have one microservice that is purely focused on saving data to Cassandra and retrieving it. That's what the Cassandra API code is doing. Whereas this service, its pure reason for being is it's processing messages from Kafka and it's sending it to that other microservice.
Oh, I got an interesting question in the chat here about, so the processor who extracts data from Kafka going to Cassandra is written in Scala. It's just to show Scala. Would it be possible to do it in Python, or is there any limitation?
Yes, you can use, so this Kafka, are you talking about Kafka streams or just the consumer API?
Yeah, the consumer is, I mean, the code you just written, just reading from Kafka, putting in Cassandra, this is Scala, but you can also do the same in Python.
Yep, you can do the same exact thing in Python. You can do it in Java, you can do it in Node, it doesn't really matter. However, the Kafka Streams API, right, this API right here is slightly different. So I can check. So Kafka Streams.
Also, the consumer, you can use any clients, but Kafka Streams expects some.
Yes, it's slightly different. Yes, exactly. So consumer producer API, is every language under the sun. I mean, pretty much. Let's see what the content has now. Let's see. It doesn't have a list here, but I'm pretty sure if you are programming in like any of the modern languages, the producer consumer API exists for every single language out there that you're using. Worst case scenario, and I'm saying absolute worst case scenario, you can use the Kafka REST proxy to put data and get data, but then you don't need to do that, all right? Now, the Kafka Streams API, which is slightly different, that's the one in which Scala definitely has native support, as well as Java. I don't think Python has that yet. I'm looking for it, but I don't think it's there yet.
Yeah, I'm looking as well, but makes sense because it's a stream with a cursor, and you just do some callbacks. So yeah.
Right. And by the way, right? So Kafka is written in Scala. So if there's any language that's going to have native support for something first, it's obviously always going to be Scala. Okay. So what's happened is that we processed 999 messages. There were 871 successes and a failure rate of about 127. Now, I know why the errors are there. A couple of different reasons why the errors are there. One is that the data had issues. There was a failure. It didn't match the schema. Other times what happens is that the Cassandra API, which is running right here, like there were some issues in the Cassandra API side. So there's always some errors that happen here. So here's a perfect scenario where, let's say we have to fix our code, right? And we needed to recover those messages. We can always go and recover those messages and replay our code and not lose anything, because the data that we have, all those 999 records are here. In fact, if I refresh, you'll see roughly about 2,000. Here we go. There's roughly 2,000 messages here, right? So all the data we've been putting into Kafka is always there, never gets lost. That's what I like about Kafka, is that you can have real-time traffic always being stored in messages. And if there's a bug, you fix it, you can just replay the messages and it'll be fine. All right, so our Kafka streams example works for the most part. There are some errors that it didn't handle well. We can always change that later. Next thing we're going to do is use something called Kafka Connect. Kafka Connect is like a lightweight enterprise service bus. It's not really an enterprise service bus. Maybe I'm going too far. Maybe it's more like a ETL framework. But what Kafka Connect does is it allows us to have an arbitrary connector to have data coming in. So using something called a Kafka source, it takes data from a Kafka Connect source and puts it into the topic. And then there's something called Kafka Connect Sync, which takes data out of Kafka and puts it somewhere. So in our example, we're not using a source. We're providing the data, right? We're creating the data. But we're going to be using a Kafka Connect Sync from Cassandra, from DataStax, excuse me, that allows us to take the data in the topic and put it into Cassandra directly. In this case, we're not using any of the REST API. We're actually directly talking to Astra from our code. So make sure I can get to the right part of the documentation here, and I will zoom in.
When we said we do have a lot of documentation, it's true. I mean, the README is just super, super long.
Yeah, if you copy and paste it, it'll work. Trust me. I think that's the big thing about any of this code, is that we don't want you to reinvent the wheel, right? If you can copy and paste it and get it to work, you can then change it and you can build upon it. Okay, so I have already, I thought I had already uploaded it. In order to run this next example, we need to upload the Secure Connect bundle that we had downloaded earlier. And I'm just going to go ahead and put it in the where it belongs. So there's an Astra credentials folder. And I'm just going to drag over the Secure Connect. Got my Secure Connect file there.
So during in the meantime, here I got a question from Gérard Goulin about, does Kafka string do any kind of transformation of message? And
yes. Good question. That's a really good question. So Kafka streams exposes your Kafka topic as two abstracted objects. One is called K-streams, and another is called K-table. And with either of those, you can operate, in K-streams, you're operating on one item at a time, whereas with K-table, you can operate on multiple kind of records at a time. But yeah, you can do anything you can do in Scala, you can do it in K-streams. In fact, if you wanted to consume the message, run a machine learning evaluation to get a prediction, and then save it back to the topic, you could do all of that in K-streams using whatever model you have, using the Scala API. You could do that. Yeah, K-streams is just Scala, right? or Java, whichever environment you're in. So whatever transformation you can do in Scala or Java, you can do with K-streams. Just, everything has a processing time, but you can do anything you want to do there. So in order for us to run the Kafka Connect example, we need to provide a, first of all, the Kafka Connect sync jar. For your convenience, I've already uploaded it here. Okay, but for any connector or sync or connector source, you would have to provide the jar. The other thing to note about Kafka Connect is that it doesn't require you to run a server or a service. You can run a connect process standalone, and that's what we're going to be doing. We're running it standalone. If you wanted this thing to run as part of a service, you can do that too, but we're not going to cover that today. So Kafka from somewhere into Kafka, and then from Kafka to somewhere else. That declaration is it's a properties file, and we're going to copy this properties file. We're not going to, if we mess up, we can come back. I can't copy here. Let's see if I can just. No, I'm just going to do this. All right. Don't get scared of this file. And the reason I say that is it can look daunting, but remember what we're doing here. We have a compiled piece of code, right? This connect Cassandra sync, which can take any schema in Cassandra and any schema in Kafka and make a bridge. That's the kind of audacious goal that this connector has. So what do we have to do? We have to first be able to tell it which Kafka instance to talk to, because it has to be able to store data somewhere. And we have to tell it which Cassandra to talk to where to send the data. And we have to tell it which fields are going to be mapped to which fields. This one file has to do all of that. And on top of that, it's not compiled, right? It's just it's a configuration file. So this is why it looks complicated, but it really isn't. I would just break it apart into like 3 different sections, right? So the first part of it here is just says, this is my sync connector. Here's the class to use in my jar, right? Only run one task at a time. If I have a bigger machine, I could say do more tasks at a time. Here's the topic that I want to subscribe to. We're going to be creating our messages using something, but this is going to read the messages. I'm giving it a timeout in terms of when it's talking to data stacks, Astra. I'm also giving it my secure connect bundle, right? What it's going to be using to connect to my Astra. So I have to change this. In my case, it's called platform. Then we have a couple other lines you have to change. I'm fast forwarding other sections here. All of this is really more refined ways to connect to Cassandra, right? That I wanted to change compression, if I want to change authentication, how many connects per second, all that I can change if I want to. I need to give it a password. So in my case, it's called anon admin. Sorry, that's username. The password is very secure. And again, I don't care if you look at this password and username, because unless you have the Secure Connect bundle, you can't connect to this Astra instance. More connectivity information for Cassandra. We're just going to fast forward this. And then finally, here's the line which tells the Connect how to map my information. So the mapping says whatever the topic is archived field is, sorry, the Cassandra column, make that from the topic is archived. And because I had the same exact names, I didn't really have to do any special mapping, right? All I'm saying is this Cassandra column is equal to this Kafka topic field, and so on and so forth. If I wanted, I could do some basic transformation in here from not just the value to value, but you can also say, create this insert statement from the data that I have. Okay. Again, we're not going to do that, but you can do some basic transformation if you wanted to. Another thing, I'll just briefly mention it. You could take data that comes into Kafka, have a Streams API manipulate it, and then have that data go to another topic that is connected via Kafka Connect, essentially doing specialized transformation before it ends up in Cassandra. In message-oriented system, it's all about
question.
topology. I'm going to
just question. If one of the message is off and you got an error, what does Kafka sync do? What does Kafka sync?
If you send a message and it has an error in Cassandra processing or in Kafka processing?
I mean, today it's Cassandra, but is Kafka sync as some mechanisms to just put the message in the letter queue, something like that?
So Kafka Connect has some basic error handling where it will try to retry if, let's say, the write operation didn't work, right? It'll have some basic retries. It's not like super robust, but it's there. In terms of the reading from Kafka, I mean, it's intelligent enough in the sense that if it didn't process the message properly, it won't process it in Kafka, right? And it'll try again until it does process.
Now I would like to. I just simply want to add that in this kind of architectures, you want your flows to be idempotent anyway. You want to be able to replay it. It's true for Kafka. It's true for Cassandra. You want to be idempotent everywhere.
Yes. Absolutely. And you want any event system to be idempotent. It doesn't matter. The moment you say you have an event source system, you are buying into that mentality. So absolutely. Couple of things to note. You don't have to just do inserts or updates. You could even do deletes. We're not going to do deletes today, but Kafka Connect is a very powerful system. Just be careful with what you're doing here. Couple other things I'm changing. I'm changing some topic. These are now settings related to the Kafka topic, right? So I'm changing the key space and the table name that I have. These are special to my instance. And there are a bunch of settings related to Kafka that I'm not touching. You can always go back and read more into this. But I believe that is it. So just to summarize, this file looks daunting, but it's doing three things. It's telling Kafka Connect which Kafka instance to talk to, which Cassandra instance to talk to, and it's saying how to map the Kafka topic to the Cassandra topic. So before we can run our Kafka Connect example, we need to stop the Kafka Connect service. Remember I mentioned that you can run this as a service? So Confluent out of the box is basically running something for us. I'm just going to go ahead and stop that. and I'm gonna empty out my my table. Okay, so connect is down. I'm going to do a couple more. Let me do a couple more checks here to make sure that I'm not running anything competing. Okay, my Python data importer is not running. Let's see, my Kafka Connect bundle. Sorry, my Kafka Connect service is down. Okay, good. What I don't want is a competing process, right? And this is the magic of Kafka Connect. With one file in a jar, compiled by DataStax,
Woohoo!
that you didn't touch, all I'm saying is run Kafka Connect using this jar and using this properties file. And it's now listening for messages. Let's see. Oh, that's okay. This happens sometimes. All right. So it's running. And I'm going to go ahead and start producing messages.
So now we don't need any consumer anymore. So this is at the Kafka Connect level that Kafka will push the data into Cassandra directly.
That's right. That's right. I'm going to double check to make sure that I did what I'm
I am in
supposed
front
to
of
do.
the log.
Let me. Okay, this is good. We have Kafka Connect, secure Connect bundle. Okay, good. All of this looks like it's okay. All of this looks like it's okay. Well, oh, here we go. Here's my problem. I did not give it proper mapping.
The key space
like
name.
The most important line in the file. I didn't give it the right. Give it the proper key space name. Okay, so it's running, and it's should be processing. You're not going to see it, but so you see how fast that went? I didn't truncate it, so that it added more stuff, but it basically took everything in Kafka, right? Because I had set the offset at a higher number, and it just put it into Cassandra. So I'm going to stop the service so that you guys can believe that, this was really, really fast. And I'm going to, so I'm going to recreate the messages. Okay, so I'm going to truncate. There's 0 records.
Okay.
I'm going to go back to my, let's see. I'm going to make some messages. Created 1,000 messages. And run the connect again. And let's do a count. So within a few seconds, it created 750 records. And it's done. all 1,000 rows have been processed and it's finished. Kafka Connect is the least programmatic way to get data from Kafka into Cassandra. But we had to do some planning. And while we were using the other examples, we did a bit of that homework, right? So we created a schema in Cassandra. We created a schema in Kafka, which matched that schema. We had a data importer that was dumping data into that topic. But when we finally connected Kafka to Cassandra using Connect, it was just one file. That's all we said. Here's where to connect to Kafka. Here's where to connect to Cassandra. Here's the mapping, and there it is. Everything is moved from Kafka to Cassandra. We talked about 3 different ways to work with Kafka today in conjunction with Cassandra. It is consumer producer API. Consumer producer APIs are 100% compatible with pretty much every programming language, C#, Python, Node, etc. Second way that we used Kafka and Cassandra is Kafka Streams. Kafka Streams is a domain-specific language inside Scala to work with Kafka data and to do processes on stream level or what's called a K-table level. And the last way that we used, that we connected Kafka to Cassandra was using Kafka Connect. What are the pros and cons? Well, if you have a team where people are programming in different languages, Kafka can provide the lingua franca, the common language between all the different systems to say, as long as you meet this schema, go ahead and create messages in these topics. It doesn't matter what programming language you use, right? Then if you wanted to do special processing and you had team members that knew Scala or Java, then you could use Kafka Streams. And in fact, if you go to Google and look for Kafka Streams topology, you'll find lots of different examples of people using a topology or a shape of the topics from one topic to another to do everything inside Kafka Streams. Okay. What are the type of things you can do in Kafka Streams? You can do lookups from other topics. You can do merges between 2 different topics. Different topics could get merged into another topic. That's a whole different subject on how to use Kafka Streams, but it's very, very powerful. I could probably talk about there's probably like a 3-day workshop just explaining what Kafka Streams can do for you. But to put it blankly, Kafka Streams allows you to do operations on the topics inside the Kafka cluster very, very easily.
I do have a question. Maybe I hope it's not a trap. When would you put Kafka Stream versus Spark streaming?
Sure. Great question. So Spark streaming. Spark is like very, very powerful. It's built for distributed computing that was meant to replace something like Hadoop. But Spark can do not only distributed operations. You can do single item operations in Spark, similar to Kafka Streams. But in that case, Spark is a little bit more heavyweight than Kafka Streams. Kafka Streams is operating on a item by item level. It doesn't have any knowledge about the whole record set. Whereas in Spark, you can have knowledge about the whole record set. You can do operations on the whole record set, and it breaks it apart into discrete memory, basically memory tasks that can do work on one record, or you can do work on one column in a whole table if you wanted to, but it just breaks down the work. You're not really doing that in Kafka Streams. So where would I use Spark versus where would I use Kafka Streams? If I knew that all I needed to do was operate on the message, even machine learning, if I have the model that's made, I can use that model in Kafka Streams. Versus with Spark, I could make a new machine learning model. I could do crunching on the whole data set. There's no way that I would want to do that with Kafka Streams. So there's really like one like little sliver of the Venn diagram where they kind of make they're similar, which is the single item processing. You could do the same thing that we're doing with Kafka Connect. You could do it in Spark, but like, man, that's a lot of work to do that. Or even joins, right? It's a lot of work.
Okay, thank you.
Okay, and then Kafka to Cassandra with Kafka Connect. This is the simplest, easiest way to get data from Kafka to Cassandra, but that's not it. Kafka Connect has so many different libraries for MySQL, for Oracle, even CDC. You can take data from one Cassandra cluster and send it to another Cassandra cluster by using the CDC connector, right? So Kafka Connect is very powerful. Why would you use Kafka Connect? Well, I think it's great for getting data from other systems from one system to another, not just for synchronization, but for just general ETL beyond, like, let's say you have to do data analytics across several systems. Kafka Connect would be the perfect tool to get that data into one place. So Spark, yes, it can do all that work, but it's way more work. So you take MySQL, you take Oracle, you take Mongo, you take all that data, and you use connectors to get it into Kafka, and then from Kafka you can stream it all into Cassandra. Once it's in Cassandra, you can do anything with that data. So I think Kafka Connect is very powerful if you use it in the right context. But I wouldn't replace application development with Kafka Connect. I don't know if that's really the right place for it. So with that, we covered everything we set out to do. We brought up the API from before. We brought up Kafka, created topics, moved messages with Python, used Kafka Streams, and finally we used Kafka Connect. And we did all of that using Gitpod, online web-based tool. So you can do all this fast data, big data stuff without having fast, big computers. And with that, I'm going to hand it back to Sandesh.
Okay, thank you very much, Raul. It was very, very useful. I really love doing all the step-by-step to review the content. It's very dense. You learn a lot. It's Python and Scala. Really love the content and really great coding as well.